Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at Lec-6 Institute of Engineering and Technology in IT-ICT Department. Welcome to the video tutorial series of the Internet of Things IoT. Today we will discuss about sensors and interfacing. Right, so this is the last session about the sensors. Right, so in our previous sessions we have seen so many sensors, right? Ultrasonic sound sensors, heartbeat sensors and all that, right? So we will discuss some of the few sensors more in this particular session. So in this session we will see the color sensor, GPS sensor, gyro sensor and the pH sensor in brief, and its interfacing with the Arduino, and some of the code explanation about how you can work with the Arduino and this particular kind of sensor, right? So stay tuned for working with this particular sensors and Arduino, right? So yes, what do you mean by the sensor? The four most basic questions. Nowadays everything we can measure with the help of the sensors, right? So the sensor is a device that detects or measure the physical property and record, indicate or otherwise respond to it, right? So yes, the sensor is a device that measures the physical input from its environment and convert it into the data that can be interpreted by either human or machine. Yes, you are right. The sensor is a device that measures the physical input from its environment and convert it into the data that can be interpreted by either human or machine, right? So yes, there are some functions there. So there are some example of the sensors, right? So we have seen few sensors in our last session, right? So which are they? First of all, we have seen the gas sensors. After that we have seen the obstacle sensors. After that we have seen that ultrasonic distance sensor, right? After that we have seen an LDR sensor, and at the end we have seen the heartbeat sensor in last, right? That are the sensors we have covered in our previous session. So yes, if you want to learn about that particular sensor, go back to our previous session and learn that, right? In this session we will see the color sensor, gyro sensor, GPS sensor and the pH sensor in brief, its interfacing with the Arduino and some of the code explanation about a particular sensor, right? So with the help of that you can work with that particular sensor and the Arduino, right? So let's begin with our first sensor, that is a color sensor, right? So what is the basic functionality of that particular color sensor, right? As its name suggests, the color sensor is used to detect the RGB color coordinates of that particular color, right? So what do you mean by that RGB color? That is indicating the red, green and blue colors, right? And its particular coordinate we can, by that particular coordinate we can detect a particular color, right? So this is the example of the color sensor, right? The color sensor module has a TSC3200 IC that converts the color to frequency by enabling a particular color diode turn by the turn, right? The color sensors module has TSC3200 IC that converts the color to frequency by enabling a particular color diode turn by turn, right? So that's how the sensor is working. The color sensor is mainly used in the application where the objects are identified by their color, right? So whenever you want to identify an object by their color, this kind of sensor is used, right? So let's see some of the pin out of the color sensors module are obviously that have an VCC which is connected to the 5 voltage, and there is a ground which is connected to the ground there, right? After that there is an S0 and S1 pins, right? So that are used as an output pin by the frequency scaling, and we have an S3 and S2 type of photodiode selected, right? So that are the basic pin out function of the color sensor. OE dash pin which is enabling for the output pin, and we have an output pin that is output frequency FN, right? So this is the pin functionality of the color sensor. We have an S0 and S1 pins, right? So what is the function of that? The combination of the S0 and S1 are used for output frequency scaling, right? Remember that the combination of S0 and S1 are used for output frequency scaling. The different microcontrollers have different counter functionality and limitation. Hence we need to scale the frequency according to the microcontroller used. The percentage of the output scaling for the different combination of the S0 and S1 are shown in the table, right? So we have an S0, S1. some output frequency scaling and typical full scale frequency, right? If we have an LL as a S0 and S1, there is a power down, right? So that is no doubt that particular thing. If we have an low frequency at the S0 and if we have an high frequency at the S1, that is at 2% of the frequency scaling, which is having a 10 to 12 kilohertz. After that, if we have an HL, in which we have a high frequency detected at the S0 pin and we are detecting a low frequency at the S1 pin, that is giving a 20% of the frequency scaling. That is giving an 100 to 120 kilohertz, right? If we have an HH, we have an 100% frequency scaling, right? So this is the frequency scaling of 500 to the 600 kilohertz, right? So that's how we are detecting that thing. After that, we have an S3 and S4 pin, which are used for a photodiode selection. The photodiodes are associated with a different color filter. We have another table which is associated with the S3 and S4 pin, right? If we have an LL, in that we are detecting low frequency at that S3 and S4, that is that photodiode is detecting and red color. If we are detecting low at the S3 and high at the S4, that is that blue color which is detected by the photodiode, right? If we have an HL, in that the H3 has the H and S4 has the L, that is a no filter. That is a clear filter, right? And if we have an HH, that is indicating the green color, right? If we have an HH at the S3 and S4, we are detecting a green color at the photodiode. That's how we are detecting that thing. Let's see the working principle behind the color sensor. The sensor works by the imparting by the bright light on the object and recording the reflected color by the object. Yes, the sensor works by the imparting the bright light on the object and recording the reflected color by that particular object. Right? The selected photodiode for color red, green or blue converts the amount of the light of the current. Right? So input of the photodiode of the color sensor. Right? After that, it is output as the RGB color values. Right? The input of the photodiode is giving an output as a RGB color values. Yes, RGB values are further proceed to identify the exact color combination. Right? That's how we are calculating the actual color of the particular object. Right? This is the working principle behind the color sensor. Let's see the interfacing with the Arduino. Right? So as we all know, how many pins are there? Right? So yes, there are mainly the VCC and the ground pins are already there. Right? So they are obviously connected to the 5 voltage and the ground with the Arduino. Right? After that, we need to enable the sensor of the OE to connect it with the ground, right? So here we are connecting OE dash to connect it to the ground. All the selection pin S0, S1, S2 and S3 are connected to the digital pin of the Arduino. That is at the pin number 9, at 11 and 12 respectively, right? As we need to enable the sensor, we need to connect the OE dash pin to the ground. Right? After that, all the selection pin, which are there? They are S0, S1, S2 and S3. We need to connect that with the digital pins of the Arduino, right? So connecting that S0, S1, S2 and S3, we are connecting with the 9, 8, 11 and 12 pins of the Arduino respectively, right? So that's how we are connecting the color sensor with the Arduino, right? The output of the color sensor are taken as a pulse count. So output pin is also connected to the digital pin. In our case, it is connected to the pin number 10. Right? So that's how we are interfacing with the Arduino and the color sensor. Let's see some of the basic code explanation about Arduino and the color sensor. Right? So here is the code. Right? So in here we are defining that thing. We have connected S0 and S1 at the pin number 9 and 8 respectively. S2 and S3 is connected to the 11 and 12 pin, and out pin is connected with the 10 number of the pin of the Arduino. Right? So initially we need a frequency of the 0, right? And after that we need to some kind of things, right? Here we need a pin mode S0 and we are getting an output from that. We are detecting that thing, right? So that's how we are detecting that thing. After this, the basic functionality of the color sensor is having, right? So here, with the help of the frequency is equal to map and frequency 30, 90, 255 and 0, by this particular statement. This syntax maps the value of the given number or variable from its defined range of the desired range, right? This is the range given by the user and we are mapping that thing with the variable, right? So that's how we are working with that. So let's see the function of the Arduino IDE. First of all, let's see the map function, right? So what do you mean by that map function? The syntax maps the number from one range to the another, right? The syntax of that map function is map. In that we are getting a parameter of value from low, from high, too low and too high. That are the basic parameter of that map function, right? So what do you mean by that particular thing, right? Value. The value is indicating that the number of the variable to the map. After that, from low, the lower bound of the value of the current range. After that, from high, the upper bound of the value's current range, right? After that, too low and too high is there, right? So too low is indicating the lower bound of the value's targeted range and the too high is indicating the upper bound of the value's targeted range, right? So that are the parameters description about that. That's all about the color sensor. Let's move forward about the GPS sensors, right? As you all are using the GPS sensor, what is the basic functionality which is providing by the GPS sensors, right? So yes, you all are right. The GPS sensor is used to get the location data of that place where the sensor is situated. The data from the sensor is acquired in the NEMA format, right? So what do you mean by the NEMA format? That is a National Marine Electronics Association format. The format is used by the Marine Department for the communication. There are multiple variants of the GPS sensors available in the market. We can select that sensor based on our requirement. So in this course, we have selected and base version of that sensor, that is GUID as GPS 6MV2. So pinout of the GPS sensors modular, as obviously we have a VCC and the ground pins which is need to connect at the 5 voltage and the ground, right? After that we have an TX, the serial data transmit, and RX, that is a serial data receiver, right? So that are the two pins for the receiver the data transmit and serial data receive. So that are the pinout function of the GPS sensors, right? So let's see the basic working principle behind the GPS sensor. So yeah, how the GPS sensor is working. The sensor is placed in the system whose location is to be tracked, right? So here the GPS device is given with the antenna for the communication, right? So here the sensor is attached with the system whose location we need to detect, right? The GPS device communicates with the GPS satellite and the satellite returns its current location in the form of the latitude and longitude, right? So GPS device communicate with the GPS satellite and the satellite return its current location from the latitude and longitude of that thing. The latitude and longitude information we are getting with the help of that GPS satellite, right? The sensor transmit the data to the microcontroller into the predefined format from which we can extract the tracked location, right? So after getting the latitude and longitude information from the GPS satellite, the sensor transmit the data to the microcontroller into the predefined format from which we can extract the tracked location, right? So that's how that GPS sensor is working, right? So let's see interfacing with the Arduino, right? As we all know, that is having an VCC and the ground pin is already there, right? So as the GPS communicates with the Arduino serially, we need to connect the TX and RX pin of the GPS with the serial pin of the Arduino, right? The VCC and the ground pin, obviously we need to connect with the 5 voltage and the ground pins, right? But we want the data received from the GPS sensor in the serial monitor also to read the current location. Therefore, we need to use any digital pin of the Arduino as a serial transmit and receiver pin, which is done by the software serials, right? So that's how we are getting an interfacing with the Arduino and the GPS sensors, right? So that's how we are connecting that GPS sensor with the help of the Arduino, right? After that, we are getting that after getting the information from that the GPS satellite, we are sending the data to the Arduino device, right? and after that the Arduino is giving some kind of information, right? So let's see the some code explanation whenever you are working with a GPS sensor and the Arduino, right? So some code, so this is the some basic code about whenever you are working with the GPS sensor and the Arduino, right? So here we need to some kind of static information about the pin number and all that things, right? So here to include the tiny GPS, we need to add this particular library, right? Why we need to add this particular library? We are including the tiny GPS plus plus library to use the built-in function for reading the GPS sensor, right? Without the help of this particular inbuilt library, we cannot get the information from the GPS sensor, right? So that's why we are including that tiny GPS plus plus dot h library as the header file, right? After that, we are including that software serial.h, right? We are adding that header file software.serial, right? This includes the software serial library to use the software serial communication, right? So that's why we are adding in some header file there. After that, the tiny GPS plus space GPS is there. Here we are defining that GPS as the object of that tiny GPS plus thing, right? So that's how we are working with a tiny GPS library. After that, the software serial access, in that we are defining that RX pin and TX pin there, right? Here the defining access as the object of the software serial, right? So here with the help of that software serial access, we are defining an access as the object of the software serial library, right? After that, the basic core functionality of the GPS sensor is likewise, right? So here GPS.encode and here GPS.encode in bracket we are writing that ss.read, right? So here in that the syntax read the data serially from the GPS and GPS.encode function encodes that data per the format, right? So with the help of this function, we are GPS.encode function encodes the data as per the required format, right? So this is the basic function of that particular line, right? After that, the display of information is there, right? So if we are getting an information as the GPS location is valid, we are getting that is latitude and longitude in this kind of formation, right? GPS.location is valid. Whenever we are getting that function, it returns true value if the location is in the valid formation, right? And after that, we are getting then latitude and the longitude function of that, right? GPS.location.let function returns the current latitude value and it is printed with the 6 decimal point precision, right? And with the help of that GPS.location.lng, right? So with the help of that particular function, it returns the value of the current longitude value with the 6 decimal point precision, right? So that is the basic code whenever you are working with the GPS sensor and the Arduino, right? So let's see some of the output function of that, right? So whenever you are working with the GPS function, this is the basic output of that particular thing, right? So with the help of that particular sensor, we are getting the location information about latitude and the longitude, right? So that is the coordinate of the that are the coordinate of that particular latitude and the longitude of that particular location, which is the LJIT, the LJ Institute of Engineering and Technology, right? So that's how the GPS sensor is giving an output from that thing. So that's all about the GPS sensor. So most ofly the gyro sensor is work within variables, right? The gyro sensor is very useful in variable device. It is used to find the position or angle of the rotation of the body, right? This mainly senses the rotation. This mainly senses the rotational motion. This changes in the orientation, right? And after that, it senses the changes in orientation. The gyro sensors communicates with microcontroller with I2C, inter or integrated communication, inter-integrated communication, right? I2C is the most sophisticated two-wire communication protocol, right? It works with the device address, and its respective data format, right? Normally, I2C is used when more number of the devices are connected, right? The gyro sensors communicate with the microcontroller with I2C, inter-integrated communication. I2C is the most sophisticated two-wire communication protocol. it works with the device address and its respective data frames. Normally, the I2C is used when more number of the devices are connected, right? So let's see the pinout of the gyro sensors, right? So let's see the pinout of the gyro sensor. We have taken an MPU 6050 as an our gyro sensors, right? So but obviously we have an VCC and a ground. We need to connect with the 5 voltage and the ground. After that, we have a serial clock line. After that, we have a serial data line. After that, auxiliary serial data and auxiliary serial clock we have. After that, we have an ADO. This pin can be used to vary the address in case of the multiple sensor is used, right? So the ADO pin can be used to vary the address in case there are the multiple sensors are used. After that, the interrupt pin is there, right? Interrupt pin is available for the certain application, right? So that is the pinout function of that particular thing. So that is the pinout function for that particular gyro sensor. Let's see the working principle behind that particular sensor. The MPU 6050 senses the gravitational force applied to it, right? It places the sensor in device whose indication is to be measured, right? Obtain the value of the x, y and z coordinates, right? This sensor is sensing the gravitational force applied to that, and with the help of that it is obtain the value of the x, y and z coordinates. It determines the elevation angle by the performing the mathematical calculation, right? The sensor placed for the finding the indication, right? That's how we are getting the information about the x, y and z coordination, right? The x, y and z coordinates, and by that we are determining that angle of that particular device, right? So that's how that gyro sensor is working, right? So in the interfacing of the MPU 6050 with the Arduino Uno is shown as in figure. Here we have an VCC and the ground pins, right? So we need to connect with the 5 voltage and the ground, obviously, right? The SCS, the SCL and the SJ pin are used to I2C communication, right? These pins are available in Arduino with A5 and A4 pins as second functionality. Hence, SLC and SDA are connected to S5 and S4 pin of the Arduino, right? The interrupt pin of MPU 6050 give interrupt when angular velocity increase than the defined threshold value. So interrupt pin of the MPU 605 is connected to the external interrupt by Arduino supported at the digital pin number 2, right? So that's how we are interfacing the that particular gyro sensor with the Arduino, right? So that's about the gyro sensor, right? So let's see another sensor which is the pH sensors, right? So as its name suggests, it is used to sense the pH level of that particular water. So as its name suggests, it is used to measuring the pH level of that thing. The pH sensor is used to detect the hydrogen ions concentration of that particular liquid, right? So that's how the pH sensor is look like, right? The pH sensor are mostly used in the laboratory to test the acidity of that solution, right? By the use of the pH sensor, we can identify the pH of the solution and whether it is acidic or the basic, right? So with the help of the pH sensor, we can measure the pH level of that particular thing, right? Either it is from the 0 to the 14 levels, right? So with the help of that, we can sense that thing. Let's see the basic working principle behind the pH sensors, right? When this sensor is placed in the solution, the smaller ion penetrate the boundary areas of the glass and the larger ions remain in the solution. This creates a potential difference. The pH meter measures the difference in the electrical potential between the pH electrodes, right? After that, the potential difference generates a different analog value for the different liquids, right? After that, by that, which is having by knowing the analog value of the standard water, the pH value of the other liquid can be determined, right? That's how the pH level of the particular liquid is sensed. When this sensor is placed in the solution, the smaller ions penetrate boundary areas of the glass and the larger ion remains in the solution. It creates a potential difference, right? The pH meter measures the difference in electrical potential between the pH electrodes, right? the potential difference generates the different analog value for the different liquids, right? After that, by that we are getting an output voltage from that. By knowing the analog value of the standard water, the pH value of the other liquid can be determined, right? So that's how we are getting then pH value of that particular thing, right? That we are detecting the alkalinity of that liquid, right? So with the help of that particular output voltage, we are determining the alkalinity of the liquid, right? This is the basic principle of the pH sensor. Let's see the interfacing with the Arduino, right? The interfacing of the pH sensor with the Arduino is shown in the figure, right? Here, the VCC and the ground pins of the pH sensors are connected to the 5 voltage and the ground of the Arduino board. The output pin of the pH sensor is connected to the analog pin of the Arduino. The connection of the pH sensor is done with the voltage converter via PNC pin, right? So that's how we are connecting the pH sensor with the Arduino Uno, right? So let's see some of the code explanation about whenever you are working with the pH sensor and the Arduino, right? So this is the basic code of that particular thing. This is the code fragment of the pH sensor whenever you are working with the Arduino, right? So define offset 0. This statement defines an offset for the correction of the pH value. The offset value can be obtained by measuring the pH of the standard water, right? After that, here it is taking in 10 different valuation, right? It is taking the 10 different value for the analog voltage from the pin where the sensor is connected, right? So with the help of this particular fragment of the code, it is taking the 10 different value of the analog voltage from the pin where the sensor is connected. And after this particular loop, we are doing an ascending ordering, right? We are sorting the element of the array buff in an ascending order, right? And by that we are sensing the pH value of that particular liquid. By this particular code fragment, we are sorting the element of the array buff in an ascending order. This code is taking 10 different value of the analog voltage from the pin where the sensor is connected, right? By this particular code fragment, we are getting that we are sorting the element of the array buff in the ascending order, right? After that, with the help of this particular loop, what we are getting? We are getting and avoiding the lower and the higher of the two. Total 4 values of the array and taking the average of that particular array for the rest of the array, right? So with the help of that thing, we are avoiding the lower and the upper of the two, right? For example, total 4. We are avoiding the lower and upper 2, total 4 values of the array and taking the average of element for rest of the array, right? With the help of this particular statement, we are converting that average value into the equivalent millivolts, right? And with the help of that pH value is equal to 3.5 into the pH value of plus offset, we are getting and converting that millivolt into the equivalent pH value as given in the data sheet and adjusting with the offset. Right, so that's how we are measuring that pH value with the help of that pH sensor. Yes, that's all about pH sensors. Thank you for the watching.